In the last video, we discussed some of the major issues with Hamilton's method, and in this video, I wanted to focus on Jefferson's method, the next method that our book gets into. And Jefferson's method of apportionment is what's referred to as a modified divisor method, and actually all of the remaining methods are going to be very, very similar to Jefferson's method. But they differ quite strongly to Hamilton's method because the method of surplus distribution for the apportionment was population biased, and we prefer our methods of apportionment to be population neutral. And some of the methods we're going to be getting into are not completely immune from bias too, and we'll kind of get into that as we go. And also what I wanted to mention is in the slides, there is a little bit of information about how do you actually and so you'll probably encounter homework questions where they, instead of giving you the populations, they give you the standard quotas to begin with. But if you take a deeper look at the formulas for how the standard quotas and standard divisors are calculated, you can actually use that information to reverse engineer it. Because as I said in a previous video, if we add up all of the standard quotas, that net value should give us the number of seats, M. And if we also know the standard divisor, or if we know the total population, like if you look at this question, it gives us P, the total population, and it gives us the standard quota. Basically, we could use those standard quotas to reverse engineer the populations by first figuring out, okay, what is the standard divisor by taking this divided by the sum of all those. And once we have the standard divisor, you could multiply the standard divisor by each of the individual quotas to get what are those individual populations. And that's a way to figure out these questions. While it is a little bit, it's definitely more annoying than just solving the question straight away. As you know by now, sometimes the homework questions try to challenge you to see, can you figure it out if we change up what is given, to really see how deeply you understand it. But anyways, this is a slide. If you get stuck on those questions, I'd advise just taking a peek at it and seeing if that helps. But anyways, let's get into Jefferson's method. So due to issues with the fairness, as we talked about, President Washington issued the first ever presidential veto based on the apportionment method that they would be used. And basically, he concluded that there was some unfair things going on, due to no divisor providing a tabulated apportionment numbers that were actually going to be used. And basically he proposed a new method, or he used a new method, which we now refer to as Jefferson's method, created by Thomas Jefferson. So if you Google it, you'll see something like this, but it's what's referred to as a modified divisor method. So it says, let D be equal to the US population divided by the number of House seats, aka the standard divisor. It says decrease D by some D so that when the state quota is equal to the state population divided by the new divisor is rounded down for every state, these values add to the correct number of seats. So this way is coined a little bit in a confusing way, but the gist of it is that if we take the standard divisor, as we've seen in past examples, and then we round it down, what that will do is it will be too small. It will give us too few of seats, and how Hamilton approached the problem was he gave out the surplus. But what Jefferson noticed is that instead of just giving out surplus seats, and also instead of using the standard divisor, if we instead decrease the standard divisor, we should be able to find a new divisor that when we use the lower quotas will actually give us the proper apportionment. And basically created the idea of modifying the divisor. And all of the remaining methods use are what are called modified divisor methods. And in the packet, I created my own kind of how to find this suitable divisor, and we'll get into that. But let's go ahead and just look at how is Jefferson's method presented in the book. And I think it's a little bit confusing in some ways, so I wanted to kind of give you my own 2 cents on this. But it says step 1, find a suitable divisor D. Step 2, using D as the divisor, compute each state's modified quota. Each state is apportioned its modified lower quota. So basically, and if you were looking at the previous slide, basically we're trying to find a new divisor that does properly apportion, and that's what we coin a suitable divisor. But finding a suitable divisor, how do we do that? Basically, one of the ways is by guess and check. We could say, well, does this divisor work? No. Let's try a new divisor. Does this one work? No. And kind of just keep trying different numbers until we find one. And there's a process of getting closer and closer to the right answer, which I wanted to sort of show you how you can do that and work on that. But the ultimate end thing to take away from Jefferson's method is he was still using the lower quota same as Hamilton, but instead of distributing surplus seats, he worked on it by working on a modified divisor. And so I'm going to introduce the term modified divisor, which is just a term for a different divisor than the standard divisor, and modified quota. Basically, just like how we have a standard divisor and a standard quota, if we change it up a little bit, that's what we're just going to call modified divisors. So basically, we can guess our way through the modified divisors until we find one that is suitable. And once we do find one that's suitable, we're good. So if we know the suitable divisor without ahead of time, it's very, very easy. It's actually even easier than Hamilton's method. But part of the trouble is actually finding a suitable divisor. How do we do that? So I have a little guide for divisor hunting, which I found was quite helpful to the students to have, because at first it was kind of a hard thing to teach because the book didn't really get into the nitty gritty. But basically, step one, what you can do is start with the standard divisor, because the standard divisor is the perfect divisor for perfect apportionment of all the numbers. The issue is that when we then round it, it doesn't work quite right anymore. And that's kind of the idea behind the modified divisor. Since the standard divisor won't work, we're going to change it up, and there will be one that does work. And there's actually mathematical proof that there must be some number that will, but we're not going to look into that sort of stuff. Anyways, step two, it says to pick a modified divisor by raising or lowering the current divisor. And there's a very easy way to determine whether or not we want to raise or lower it, which we'll get to when we look at an example. It says calculate the modified quotas, compute the sum of all the modified quotas. So this is exactly the same. Basically, we're going to take SD, change it up a little bit, divide everything by it, round them all off, and then if it says if it's not properly apportioned, you are done. Sorry, it says if it is properly apportioned, you're done. If not, repeat steps 2 to 4 until a suitable divisor is found. So basically, guess a divisor, compute. Did it work? No. Try again. Try again. Try again. It is quite tedious, but that's kind of the idea. So let's do an example of using Jefferson's method to figure out an apportionment problem. And there's actually another critical idea that I wanted to get at before we jump into an example is how do we know whether we want to lower or raise the current divisor? And there's actually an easy way you can check. And actually, we'll return to this once let's go ahead and set up the numbers. So let's return to the same example number 2 that we did with Hamilton's method, where we had 6 states with populations given below. And we found the standard divisor, which was 50, and divide them all through to get all this. So basically, under Hamilton's method, we would round them down and do surplus. But under Jefferson's method, it's very similar because we're still rounding down. So that's one very similar aspect to Jefferson's method. If we use the lower quota here, we're going to get 32, 138, 3, 41, 13, and 19. And that total was 246, if I recall correctly, and it did not add up right. So we know we're not done, and the standard divisor was not suitable. There is a chance that the standard divisor could be suitable. Actually, it can't happen for Jefferson's method, but under Webster's method and the Huntington-Hill method, sometimes it can happen, but again, it's not. Typically, the standard divisor does not work, but it's not impossible. It depends on the type of rounding that you're doing in each case. But basically, what we can say is that does not work. So what do we do next? Well, now we want to modify the standard divisor. And so basically, I'm going to start with 50, and I want to change it. I want to tweak the number, but basically, I'm going to do the same process. I'm going to divide through all of them again and round them all down, find the modified quotas for each case. But the question is, what do I pick? Should I make this 51? Should I make it 49, 42, 57? Like, how do I know? And that's kind of what I wanted to begin with, is how do I know whether I want to raise or lower it? So if we really think critically about what's happening here, what we did is we started with the populations and we divided them all by 50 to get the standard quota. And notice that if we round them down, we're left with too few of seats, right? So what that's kind of saying is that these numbers ended up making a sum of numbers that were too small. So our goal, since our goal is to properly apportion 250 seats as we had, we want more seats to be given out. With Hamilton's, how we fixed that was by surplus, but that led to some issues. So with Jefferson's method, there's a different way of fixing the quotas. Instead of using the standard divisor, if we notice that if we think about should we increase it or decrease it, if we were to take the standard divisor and increase it, what would happen is we're going to be dividing each of these numbers by a larger number. And what happens when you divide by a larger number is it actually gets smaller. So this is just something I wanted to note. If we increase the standard divisor, what actually happens is the quotas will go down. Whereas if we decrease the standard divisor, so meaning I'm going to take these numbers and say make this smaller, I would then be dividing by a smaller number, which would in turn make the quotas go up. So there's an inverse relationship, mainly because we're dividing, between a change in the standard divisor and a change in the quota. So when we so sort of the summary here is that since this quota was too small, I want my quota to go up, which means that I want to lower my standard divisor. And so basically you kind of want to, it's often the opposite of what you might initially guess as to how you want to change your standard divisor. So basically if I'm trying to think of what do I want to do to my standard divisor, I want it to go down so that I give out more seats, because when I'm rounding down, that's going to be too few and I want to always do more. And something you can remember about Jefferson's method is the standard divisor should always be smaller than the standard divisor. Sorry, the modified divisor is smaller than standard. But anyways, otherwise, how do we know what it will be? Well, we kind of have to guess. And usually after one or two guesses, you'll get a pretty good sense of what your answer should be. But let's just say we have no idea what we should modify our divisor to be. Let's just say we pick 45 just for, or I don't know, for the sake of a random guess, because we have no idea what to do. And what I'm going to do is I'm just going to, what I recommend doing is taking note on what your divisors are, because if you don't keep track of what math you did, you're gonna lose track of what is going on in your problem. And since we're tweaking the standard divisor in these methods, you know, if we don't keep track of what we did, we're never gonna find the right answer if we're never keeping track. Anyways, basically. So what's the difference? Well, I'm just taking a new divisor and I'm going to divide each population by the modified divisor. So basically I'm going to do the same thing I did before, take each number, but now I'm just dividing by 45. And it was sort of a random choice in this case to see, well, will this work when I do these, when I pick a new divisor? And to be honest, I don't remember what the right answer is, and that's part of the process as well. Just sort of guess. So the modified quota for state A will be 36.58. The modified quota for B will be 154.13. For C will be 30.42. And let's go ahead and finish the rest. And notice that I like to write my modified divisor right next to the row where I'm doing it. So that way I know how did I get these numbers, and I could go back and double check later if I wanted to see, okay, what if something doesn't make sense and I'm pretty sure I messed something up. It's a way of looking at it later. But let me go ahead and finish each of the divisions here. And D will have a, we'll have a quota 46.47. And these would all be the modified quotas based on the modified divisor, 21.95. And so then I want to pay attention to, well, what method am I using? I'm using Jefferson's method, so each of these will be rounded down. Again, and there's no such thing as surplus or anything, because that's only what we use for Hamilton's, and you want to completely pretend you don't know anything about Hamilton's method when using Jefferson's method. So anyways, once we have tweaked our apportionment here, using a modified divisor of 45, we can see that we get a very huge difference in our outcome here. And it appears as though, well, if we, I apportioned way more seats than I did before. And if I add all of those up, that surely will not be right. But let's go ahead and figure out the sum. When you're done, you always want to make sure to add up your answer, because you want to know, well, how do we know if it worked? It worked if it worked. And that's really, there technically is a more enlightened mathematical way of doing this, but it's way more complicated than we're going to get into for the sake of this class. But notice how that answer was way too many seats. So my conclusion is, okay, technically that was better because this was under apportioned, this is over apportioned, but this was way over apportioned. So what I'm kind of concluding about this choice in modified divisor is I went way too far. from the standard divisor was 50, 45 was too extreme. So what I might try next as my next guess for modified divisor is maybe 49, and we'll see maybe does that one work instead, because 45 was definitely too big of a gap. And you can kind of use your guesses to hone in on the right answer, since 50 was way closer to 250 than this one. And then we kind of rinse and repeat. So let's do it again. And now we just need to use 49. So I'm just going to do all this for a second. And actually, you can do all of this math in Microsoft Excel as well, which makes your life easier. But for exams and stuff, I'm not. That's not a resource that is technically allowed. So I'm not going to really bother using it. But in this case. But anyways, let's go ahead and get the rest of these numbers. So the modified quota for using the divisor 49 will be 20.1. Also, notice how the decimals, since I'm rounding them all down, it doesn't really matter what they are at the end of the day, because they're all going to be rounded down anyways, because that's just Jefferson's method. And you might be wondering, well, why are we rounding down? And that's exactly what the founding fathers wondered, which is how the other methods worked. But anyways, if we want to see if these methods worked, we need to check all the rest of the numbers. So I'm just going to try to write all these down. So we had 3.14, which is 3, 141.6, which is 141, and 33.6, which is 33. And this ended up giving us this many. And if I add all those up, I could check to see, okay, did that actually work? 33 plus 141 plus 3 plus 42 plus 13 plus 20, and that adds up to 252. So that did not work either, but it was actually closer. And the point that I wanted to make about the modified divisor method is and this is another thing you might be wondering is, well, is it guaranteed to be a whole number, or will I have to go into the decimals? Sometimes it really depends on the numbers, but sometimes it might be possible that you won't be able to find a suitable divisor that's a whole number, and you might have to go to, say, 49.2 or 49.3. But that's kind of the reality of these sorts of questions. But there is an existing divisor that will work for this problem. It's just a matter of finding it. So let's continue looking to see if we can actually find one that works. But in Excel, this is something where you can kind of program it to, you can, instead of having to redo all these calculations manually every single time, you can generate a spreadsheet that you can guess your divisor and it will automatically do all the math for you. So it's very easy to do these sorts of methods using computers, but a little bit harder to do it pencil and paper. But since, those resources will not be allowed on a test, I think it's important that we practice doing them manually. But let's say we try 49.5. To be honest, I don't even remember if this works, and I'm hoping it does, because I don't know how much longer I want to be doing this example for, but this is a reality with Jefferson's method. And it is, important that we actually find one that works. So what I'm going to do is I'm just going to write the rounded answer, because that's what we're going to get at the end of the day anyways, and the decimal doesn't really matter. Just it matters that I remember to round down. But let's try 49.5 for each of these. So I'm just taking each state's population and dividing by this next guess. So that would be 33, 143. And I'm going to go ahead and round them down too. And then we'd have 2091, 685, and 988, which would leave us with 42, 13, and 19. And actually, it appears as though that lost 2 seats from before, so that divisor will actually work and properly apportion to 250. So our final Jefferson apportionment will be, once I actually find a method that, find a divisor that properly gives out the right number of seats, that's when I'm done, and there we go. In the next video, we will do another example, but what I'm trying to hopefully emphasize is the guess and check process, but also how do we find the right answer and how do we guess? It's a matter of trying to figure out how to get closer and closer. And you may have been wondering, well, how did I know to pick 49.5 there? Sorry, the decimal point got messed up from my tablet. That's not 4.95, that's 49.5. It's kind of like, well, 50 generated this answer. This was too few. So I needed to decrease it to increase the seats. 252 was still too many. So it's like it's kind of like a sandwich where I'm getting closer and closer and closer to the right answer. And it's sort of boxing it in, and eventually you're going to be able to find it, assuming you don't go the wrong direction.